Hello everyone, welcome to week 2 lecture videos. Our today's topic is risk and return revisited. We have 3 learning objectives today. The first one is understanding risk and return and their implication for financial markets. The second one is to discuss different utility preferences theory and their implications for portfolio evaluation. And in the third one, we will be discussing risk and return on long-term investment. So I will be uploading 3 separate videos on these 3 learning objectives. The first one is develop an understanding of risk and return in financial markets and their implication. In order to develop portfolios and subsequently evaluate performance, investors are required to develop a clear understanding of what is meant by the concepts of risk and return. So the basic understanding of risk and return goes back to the idea of utility theory. So the question is, what investor actually seeking to achieve when they invest in financial markets? All investors seek to maximize their utility. That's the very reason they participate in financial markets. So when we are trying to evaluate performance of a portfolio, our question is how we actually maximize utility for individual. So the question really becomes, what is utility and how it is measured? Well, utility is an abstract concept that can be summarized as measuring the overall satisfaction that one gets from investing. But if we try to measure satisfaction, we are actually measuring something largely intangible. In financial market, we should be able to measure performance. That's why somewhere we should be able to measure utility. So a starting point could be understanding diminishing marginal utility. So this principle states that the more of a particular good you get, the less value you actually achieve. So a simple example economists usually provide to make this point clear is when you purchase a can of Coke in a hot day. Imagine that it's a very hot day and you're really thirsty, seeking a drink to quench your thirst. Now from the first Coke, you get a lot of utility because you feel really good after you drink the Coke. However, from the second Coke, you might get a little bit of less utility. And for every subsequent Coke you purchase and drink, you are getting less satisfaction, less utility. So this principle can also be applied in the case of wealth. The value of every additional dollar is actually less to you the more wealthier you are. This is a very straightforward concept. Let's say I am giving a $100 note to 2 persons. One is a multi-billionaire, whereas another is a poor university student with only, say, a couple of $100 income. Now, who has this higher utility for this $100 bill? Definitely the poor university student. So, diminishing marginal utility principle states that the more you get, the less utility you actually achieve. Now, what's the implication of this utility theory in terms of wealth? If you look at this diagram, let's say you have an opportunity where you toss a coin and for every head you get 150,000 and for every tail you get 50,000. So the expected value is 100,000 and this is the utility you get from this opportunity. Whereas you have another alternative where you will get a certain 100,000. So the expected value of this alternative, I mean 50,000 for tail and 150,000 for head, and expected value of the certain 100,000 is the same. However, you can see that utility for this certain $100,000 is higher because it is less risky. So what's the key idea or key takeaway from this discussion? The key takeaway is the wealthier the investor becomes, they become more risk averse. So they will want more return as a compensation for every additional unit of risk. Now, when we are talking about return for an investment or a portfolio return in a financial market, we actually should be focusing on expected return rather than the past returns. Now, you know that expected return has two components. One is the risk-free rate of return, another is risk premium. Risk-free rate of return is the rate of return that is earned from a risk-free investment. And risk premium is the additional return we want for taking additional risk. Now, that actually brings up our risk and return relationship. Higher risk, higher the risk premium, so higher the expected return we will expect. And another point is, as I mentioned earlier, that as we are talking about portfolio management, we should be interested about expected return rather than historical return. Because in a perfectly efficient market, the past return is a very bad proxy for predicting future returns. Let's take this example. Let's say that you are in a casino and you are spinning a roulette wheel. It has 37 slots. So what's the probability that the roulette wheel will be stopped on 0? Since there are 37 slots, the possibility that it will be landed on 0 is 1 by 37. Now, if I ask you the question in a different way, that what's the probability that the roulette wheel will be landed on 0 given that last time it landed on 0? The possibility is still 1 by 37 because whether it landed on 0 or not last time doesn't have any implication on whether it will be landed on 0 this time. So if we believe on efficient market, and if a market is reasonably efficient, then expected return will be a good proxy for future return rather than our past return. Let's look at another example. This is equity returns of United States from 1945 to 2010. So I have divided this period into 5 approximately equal periods, and these are number of years for each of this period, and these are terminal values. So if you have invested $1 for this at the start of this period in 1945, after 20 years, the terminal value would have been $6.91, and the return on investment would have been 591%. So you might think, well, that's the return for the first 20 years, so that should be a good proxy for the return of next 20 years. However, approximately next 17 years generated a return of negative 6%. And what about the next 18 years? Its yearly return, next 18 years, the total return was 1,086% and terminal value was $11. And from 2000 to 2010, obviously that incorporates a global financial crisis, and the return was minus 19.70%. So you can see that past return is a bad proxy for future return. So you might ask that, well, then what's the alternative? Alternative is capital asset pricing model that is popularly known as CAPM. So CAPM actually measure expected return as a function of risk premium. So in CAPM, we actually estimate our risk premium given the level of risk, and we calculate our expected return. Now, what do we mean by risk? Well, traditionally, the term risk is more commonly connected to a negative connotation. So risk is more commonly used to indicate something negative. Okay. However, as far as financial market investment is concerned, risk not only indicate something negative, it also indicates something opportunity. Well, as I was saying that risk in financial markets really means uncertainty. It means variability of possible outcomes. Therefore, risk does not necessarily have to be an entirely negative concept. In some ways, we can think of Chinese symbols of risk, which is reproduced in this slide, as giving a much better description of what risk actually means. Because in Chinese symbol, they have got a combination of both danger and opportunity coming together. So danger and opportunity, that's what's very much risk in financial markets. When you have uncertainty, you have an increased variability of possible outcomes. With that increased variability definitely comes danger, possible downsides, but also comes the possible opportunities, because the range of outcomes are getting broader. Hence, you also have got more upside potential from a risky asset as well as more downside potential. So when we think about trying to maximize an investor utility, when we think about the ideas of risk and return, the most commonly used measure of utility in financial market and in terms of portfolio theory is evaluating performance of portfolio is mean variance utility. So mean variance utility is really important because it assumes that the investor utility actually comprised of two elements. So the investors only care about expected return and risk of their investment. That means investors only look at the risk and return trade-off, nothing else. Whereby the higher expected return they want and they dislike higher risk. However, more importantly, under mean variance utility, risk is measured as the variance of the asset the investor is holding. So we think of these terms in terms of statistics. Expected return is just the mean or the average return of all possible outcomes. And as we see in this equation, the risk is the variance, where basically is the statistical measure of the spread of possible outcomes. We think about this as a distribution. So if we look at this example, so we have a possible investment where there are different state of economies and the possibility of these different states are like this, and we have the return in each possible state. Now, if we want to calculate expected return, we will simply multiply the returns in each state with the corresponding probability, and we sum them up to get expected returns. And to get a variance, what we actually do is, first of all, we get a square deviation of the individual returns from the expected return, and we multiply by the corresponding probability. We sum them up and we get the variance, and as we get the square root, that's a standard deviation. That means the variability of the return. So this is the story of equity market returns. And you can see this is annualized percentage return from 1900 to 2004, about for a century for different countries. And you can see that returns are historically about 10%. Probably Japan has the highest return over the century, that's 12.5% this annualized return. And probably Switzerland has the lowest, 7.6%. The blue bars are the nominal return and the black bars are the real return. So this is the standard deviation of returns around the world, and the black bars indicates the standard deviation of equity returns, and blue bar indicates standard deviation of bond returns. And very logically, equity returns have higher standard deviation, so they are more risky compared to standard deviation of bond returns. Now, investment management is pretty much easier when the returns are normally distributed. Because when returns are normally distributed, it actually have a symmetric shape. That means half of the returns will be the right-hand side of the mean and half of the returns will be the left-hand side of the mean. But so if you look at this example here, in the horizontal axis we have different possible returns, and in the vertical axis we have the probability of returns, and this is the mean return. So half of the returns will be in the right hand side of the mean and half of the returns will be in the left hand side. You understand that higher this is spread, higher will be the risk. For like if you look at this standard deviation, as this spread gets larger, the returns series become more riskier. So if you look at this example, this is a distribution that's denoted by F, and this is a distribution denoted by B, and definitely you understand, you see that A is less spread compared to B, so A's standard deviation is lower than that of B. That means A is less risky investment alternative compared to B. Now, how do we measure risk? Well, so when we are deciding whether an asset to be included in a portfolio or not, in that case, we are not very much concerned about the risk of an asset itself. Rather, we are more concerned with the effect that the risk of the asset is going to have on the risk of our existing portfolios. So what we need to consider is the marginal effect that asset will have on the portfolio risk. That's why the idea of systematic risk or beta comes in. Because we know that the risk of an asset is divided into two categories. One is the systematic risk and other is unsystematic risk. So unsystematic risk is the firm-specific risk. So that's only associated with the particular asset, and actually it is eliminated through diversification. Systematic risk, on the other hand, is a measure of exposure to markets. So it explains the risk of a diversified portfolio. If the component of this risk cannot be eliminated through diversification, hence it gives us a measure of the marginal effect that the asset will have on a portfolio. So if you are measuring the risk of an individual asset, we consider that asset as being part of an overall portfolio. Hence, we think about the risk as being just the marginal contribution the asset will have on the portfolio. So that brings this equation we see at the bottom here, the CAPM, the capital asset pricing model, where expected return on any stock should be the risk-free rate plus beta. That's a measure of our sensitivity to excess return to the market, and excess return is the market return minus risk-free rate. So this beta is a measure of systematic risk. We can actually calculate the systematic risk by finding out this line in a regression equation. So if we have a diagram like this where we have market return and where we have the excess return on individual stock, and if we find out this regression line, then the slope of this regression line is the beta for a particular stock. So we actually can estimate this beta by running a regression model where we basically regress excess return on the excess return of an individual stock on market return. Then the intercept that we get is a measure of unsystematic risk, and the beta coefficient that we get from the regression model will be a measure of systematic risk. And if we regress excess return from an individual stock on the market return and run a regression model, we get this result. So this is the intercept of the regression model. So that's a measure of unsystematic risk. The firm-specific risk, and this is a measure of the beta or the systematic risk. So you can see it's 1.17. So the risk, systematic risk of this stock is slightly higher than the risk of an average risk portfolio. So it also should have a return slightly higher than the average risk portfolio or a market portfolio. Now, there are some problems associated with the CAPM type of model. To implement the CAPM model, the first difficulty is we need to specify a risk-free rate, and also we need to specify a market return. Okay, so sometimes it might be difficult in specifying a risk-free rate and market return. And also empirical evidence provides that CAPM model sometimes is not sufficient explaining the variation in expected returns. Okay, and CAPM model is also based on only on market return. However, the expected return of an individual stock may be subject to some other factors apart from the market return. And the individual stock return also can be sensitive to some irrational exuberance rather than the fundamentals all the time. And also it depends on only non-diversifiable risk or the market risk. However, if a portfolio is minimally diversified, then firm-specific risk can also be a factor. So that's the end of our discussion on learning objective 1. Please watch the next video for learning objective 2. Thank you very much.